In the next three examples, we want to do essentially the same work. We want to look at simplifying a given rational expression. In order to do that, we want to identify common factors and try to cancel or reduce those. The way these expressions are written, though, there's nothing that obviously cancels. So the first step that we'll need to take is to factor each of these trinomials. Well, they're not trinomials in each case. Factor each of these polynomial expressions, and then see if we end up with any common factors that can be canceled or reduced. In the numerator, in example 4, we have x squared plus 5x plus 6. That will factor as x plus 3 times x plus 2. And in the denominator, we have x squared plus 8x plus 12, which will factor as x plus 6 times x plus 2. Once we have a factored expression, we have these factors being multiplied by each other in both the numerator and denominator. Now we can try to identify any factors that are common or can be reduced with one another. In this case, we have x plus 2 as a factor in both the numerator and denominator. So those will both cancel out with each other or divide out, leaving us with 1. So our final result here will be x plus 3 over x plus 6. Keeping in mind that we still have to treat each of these as a factor, meaning we can't cancel through the addition, the 3 and the 6 won't reduce here. We would need x plus 3, that entire expression in the numerator, to reduce with that entire expression in the denominator, x plus 6. So we need to recognize that's the end of our work for that problem. In example 5, we have a binomial divided by a trinomial. We'll again look at factoring. In the numerator, we have difference of squares, since this is the same thing as x squared minus 7 squared. We can rewrite the numerator as x plus 7 times x minus 7, and the denominator of x squared plus x minus 42 will factor to x plus 7 times x minus 6. Once we complete that factoring step, then we look for any common factors, which in this case, we have x plus 7 in the numerator and denominator. Those will cancel, leaving us with x minus 7 over x minus 6. In example 6, we have a trinomial divided by a binomial again. Or I'm sorry, I guess that was flipped in the last example. We have a trinomial and a binomial again. We'll look at factoring the expression that we have in the numerator, which will factor as x minus 7 times x minus 3. The expression that we have in the denominator doesn't immediately fit any factoring patterns that we have. We have a binomial, so it's appealing to think of difference of squares, but 7 is not a perfect square. What we'll do instead then is look to see if there's a greatest common factor between those two terms, and in this case there is. We can factor out a 7 between those two terms in the denominator, which will leave us with x squared minus 9. Once we pull out that greatest common factor, now we do have difference of squares, because this is the same thing as x squared minus 3 squared. So we can rewrite our expression as x minus 7 times x minus 3 divided by 7 times x minus 3 times x plus 3. Once we pulled out that greatest common factor, then we did have something that fits that pattern for difference of squares. And now we can cancel x minus 3, that factor that's common between the numerator and denominator, leaving us with x minus 7 over 7 times x plus 3.